afternoon, everyone. Hope you guys all had good lunch, and we'll try not to put you to sleep. So my name is Risha Ravindranath. I'm a senior manager at Effectv, talking here today about increasing trust in your data, implementing data governance at Effectv. Before I do any of that, I want to start by thanking some of the key members of this journey. First and foremost, my Effectv team and leadership who are here to support us. Without them, none of this would have been possible. Secondly, Jamin and Shashank, our Databricks partner, thank you. Last but not the least, our Slalom partners who were with us throughout this roller coaster ride of our transformation journey, which we plan to take forward. All right, so let's dive into the content. For some of those who are wondering, what is Effectv? Who is Effectv? Let me briefly give you a two-line description. Effectv is a Comcast unit that uses its first-party data to target their advertisers' potential customers on every screen, right from linear TV to digital streaming. Today, I'm here to talk about our transformation journey, our digital transformation journey through data and analytics, a key element of our success to reach our vision, our mission, our goal. To make this journey more relatable, we've divided into 3 sections: call to adventure, crossing the threshold, and the approach. In call to adventure, we'll talk a little bit about our destination, some of the industry challenges. In crossing the threshold, we'll identify where we need to go, and finally the approach, where Maggie and I will take you deep dive into what we're doing in this journey. All right, so I talked a little bit about Effectv, right? Let's just nail down our vision. Our vision is to be that world-class audience delivery company that uses data and targeting to engage their advertisers' potential customers on every screen, from streaming to linear TV. We're sure this is what we want to do, this is what we want to be. We want to be that world's smartest audience delivery company. But how do we get there here? What do we do? We started by taking an honest look at our readiness to be that world-class audience delivery company. The required self-reflection and assessment needed for journey was scary, difficult, and to some thrilling. However, as teams began to participate in this assessment, a fellowship across the organization formed and our journey truly began. One of our primary focus was to understand our state of data, our systems of origin, our ownership, our accountability, and just the general use case across the data. The Effectv Fellowship formed this massive list of data and inventory, reporting inventory. This list was a beginning of understanding of all things data in our organization. We also interviewed several data users across the organization to understand their thoughts, their feelings, and all the in-between. From this, we uncovered our thorough understanding of business needs, our willingness to partner together across our efforts, and just pockets of collaboration and optimism and pessimism that they were feeling for our path forward. The key themes that surfaced were ownership, accessibility, quality, security, and use cases of the data across our organization. Good, now we knew where we were. Now it was time to cross the threshold. Before we do anything, collectively, we knew that we wanted to identify ourselves in data domains so we can align and come to consensus on the focus area that we wanted to address. The key domains that we identified were customer, audience, supply, measurement, and attribution. Customer, in terms of Effectv, are agencies and advertisers that we do, have done, or will do business with. Our sources of data for this domain is essentially our CRM systems, order management systems, and marketing systems. Audience is our first-party data that we use for targeting, and these are essentially the households that we use for targeting for persuasion of our customer ads. Again, the source of the data are some of our Comcast first-party data as well as some external data sources. Supply encapsulates our inventory for advertisements across linear and digital platform. These are, simply put, these are the spots that we use for our advertisements. These are, again, the source of our data here is some of the internal and external systems. Measurement and attribution, they sort of go hand in hand as they quantify the delivery in terms of Effective's ad impression, as well as the solution that we provide to drive outcome for our customers. Awesome. Now we had nailed down our data domains. It was time for identifying our key tenants that will enable our approach. These were the tenants that we want to focus our approach on and that we want to build our technology on. These were identified by interviewing our stakeholders as well as some of the discovery sessions. One of the first key tenets that we focused on are governed data set. We needed to ensure that our data is consistent, accurate, and clean across the organization to drive insight. The second one was consolidated platforms and tools. Within consolidated platforms and tools, we wanted to drive better and faster insight with our governed data set to remove challenges from our pathways of our data scientists, analysts, and engineers. Decision engine, to build and integrate ML models for real-time and batch processing. Finally, self-serve analytics, to enable analytics practice and generally democratizing the data across the organization. Armed with the knowledge of our data domains and clearly defined key tenants, we know that we wanted to start diving into our approach, and we knew what we wanted to do. It was time to focus on these tenants and start building our approach. The first thing we needed to do as we embarked on this journey is to build that data governance framework in our organization, right? We wanted to ensure that our data is across the organization and all the way to our customers is clean, concise, and accurate. For that, we partnered with Slalom, who brought in their industry knowledge and helped us implement data governance framework across our organization. As you can see on the screen, our framework focuses around 6 main pillars. The very first pillar of policies and standards will enable us to establish data definitions, common understanding of naming conventions, nomenclatures, and standards that will help us ensure the data across our organization is governed and well protected. Within organizations and skills pillar, we created roles that are chartered and empowered to define and manage data governance-related activities. We also ensured that we identify all relevant key stakeholders that will enable data governance operating model. We are trying to create some role-based training that will help our staff and team members to just carry out their day-to-day data governance activities with ease and understanding. Within security and privacy pillar, we ensure that security standards that are set by Comcast Corporate Security Risk Assessment team are well established within our technical infrastructure, as well as data as well within the bounds of privacy guidelines. Within process, we identified and assigned business ownership of the data. It was very important for us to identify and differentiate between business owners versus data owners versus system owners. Next up, in measuring and monitoring, we established a standardized process for data intake process with a clear feedback mechanism that helps us understand that if the product is still being used and if the data is still being needed. This also enabled us to sort of apply data quality measure that we then tracked and adjusted as needed. Lastly, with technology, the most important pillar, we enabled the processes and practices for data management. We leveraged technology tools for data management, workflow management, processes, and data quality above all. Let's quickly take a look at data governance operating model that we've implemented within our organization. Here you see 3 layers, executive, strategic, and tactical. Within executive layer, our executive leadership team defines the standards and policies for all data governance-related activities. They oversee strategy and vision, of the programs while ensuring robust funding is available throughout our efforts. Above all, the biggest thing to me, which they are doing right now, is driving consensus across the organization to drive culture and change enablement. Within strategic layer, we've identified council members across various business units that will sort of do strategic planning and devise and prioritize activities for data governance. They are primarily responsible for and taking decisions on access management, data quality, and uses. Within this layer, we've also identified stewards who sort of work on daily basis with data enablement team to put data governance requirements into practice. Lastly, within tactical layer, we have the program manager group who sort of monitors and coordinate all the program management related activities and works with data enablement, data governance team essentially, to sort of understand the local business units requirements around data governance and help us implement it. This wraps up my small talk on Effective's transformation journey. With that, I'll hand this over to Maggie, who will further our conversation on approach. Over to you, Maggie.
Thanks, Risha. All right. Hi, y'all. I'm Maggie Davis. I'm a principal consultant from Slalom. I'm based out of Philly. Go Birds. I've had the pleasure of working with Effectv for the past year, building out what they call the Data Hub, which is an analytics platform created really centered around Databricks lakehouse architecture. So I'm presenting a fair amount of nitty-gritty content. So if nothing else, I want everyone to walk away from this conversation with 2 key messages. So number 1, it is possible to marry engineering and machine learning with data governance to achieve scalable master data management. And number 2, and this is mostly for my engineers, the business knows so much more than we do about the data. Don't try to solve problems without them. So before I jump into the architecture and model, here's a high-level overview of where we started. So common data challenges that you'll see in many large organizations is that data is spread everywhere. There's multiple people who own different versions of the truth. The quality of the data is mixed throughout the organization, and then there's not a lot of insight into key problem areas. We took our time to carefully architect a lakehouse foundation using Medallion Architecture on Unity Catalog before we ingested any data. So by the end of this phase of work, we had a full lakehouse with multiple data sources across a couple of data domains, ingested, cleaned, transformed, matched, deduplicated. And the goal for us is to deliver certified data sets that represent a single governed version of the truth to enable better business outcomes. All right, so here are some basics I know that are pretty familiar for most of us. So a medallion architecture has 3 layers, bronze, silver, gold. You think of these as progressive layers where the quality improves as you move across the layers, across the medallions. But each layer still has a distinct purpose. So bronze is where you find your raw data. This is useful for things like data science use cases, data quality trending, and keeping a historical view of your data for auditing and tracking purposes. And then silver is where you have your certified data sets. They're still at a pretty low level of granularity, so pretty fine. And then, but it's still general enough to serve multiple business use cases, multiple areas of your business. And then gold is where we create use case-driven specific slices of your data for a specific dashboard, for a finance report, et cetera. Earlier I said we took our time to design the foundation of the lakehouse before we ingested data. And this was our big idea. So Unity Catalog provides an opportunity to add a third namespace level. So the challenge is really using it to its maximum potential. This is the first time we look at our data governance friends. So each catalog that we built is one-to-one with a data domain. And we did this for a couple of reasons. One, I can look at any table in the data hub, and I can know a ton of information about it right away. I can look at the catalog, and I know who owns the data. I can look at the database. I can know who my data SMEs are. And I look at the table and what layer it is, and I know generally what the quality of that data is going to be, what I can expect from it. And then two, this is a very achievable way to build out domains over time and organize a roadmap to work towards data transformation goals. All right, so this is a quick flash of our reference architecture. The main point here is just to show you how elemental Databricks is to the data hub. And specifically, Unity Catalog is really the backbone of everything that we have. All right, moving away from architecture now, let's talk about machine learning driven MDM. Effectv estimated that about 50% of their data in their CRM system was duplicate. And this makes sense. This is human-entered data. It is data that has been built for a long time through many policy changes, through upstream and downstream requirement shifts, and a lot of teams with slightly different rules and needs for their data. And I know my data governance friends can relate. We had hundreds of thousands of records. And we looked at account name, for example, and we could see so many potential matches. And this is causing just a multitude of downstream issues. So the challenges coming up are across teams asking questions like, what account do I use to invoice? What is the total spend of my customer? What account do I even schedule advertisements for? And what really is even my customer hierarchy? So at a scale like this, there's no way for people to go in and possibly deduplicate this by hand. And so then a simple approach could be fuzzy matching, right? So we could fuzzy match on every pair combination, but that was like 112 billion, so fuzzy matching can't scale. Our goal was to scale out a technical solution to propose matches, reduce the search space so that we weren't looking at 112 billion combinations, and make something that we could apply outside of just this use case, outside of just deduplicating CRM. Okay, let's get nerdy. There are 4 stages to our ML process to identify potential matches. There's data preparation, NLP featurization, building the graph frame, and classification. So data preparation is the process of ingesting data, cleaning it, massaging it, normalizing it, and potentially joining it with other contextual data sets. NLP featurization is the process of taking language or strings and converting it into a numeric representation that can be used for machine learning. And this is something we do because the algorithm cannot identify patterns across strings efficiently, and it expects numerical input. Then we build the graph frame by taking each of the vertices and connecting them by adding the blocking keys to form your edges. And I'll get into that a little bit deeper in a moment. And finally, classification. So first we calculated a couple of distance metrics. In our case, we used Levenshtein distance and token overlap. We took a weighted average of these distance metrics, and that becomes your similarity score. So why multiple distance metrics? Because more evidence of similarity is better than less. So if my FICO score and my experience score are the same or similar, I can feel pretty confident in them representing my actual credit score. All right, so now let's get less nerdy for a second. This is a lot of engineering, but I said everything is done in partnership with the business. So right before we start this process, we do a ton of data normalization. And I'll get into like the details of that in a moment, but basically you can't match on crappy data. And the engineer needs the business to help clean it up. So that is business partnership number one. Number two is deciding how to weigh different fields that we use when featurizing the account data. So you decide how to weigh the different fields, and that requires domain knowledge. So I can make some educated guesses about what fields I think will help me propose possible matches or find a unique advertiser. But we were actually pretty surprised at how many nuances the business showed us about what data to really consider. All right. Here's an example of how the preparation and featurization process might look for an account record. So the truly unsung hero of this process happens right before the MDM piece, which is standardizing your data. And this is where you work with your business to clean up the data that you want to match on. So your features, your blocking keys, and your stop words. And yes, like, we data engineers can clean up nulls and we can find weird characters and clean those up. But talk to your business. They know why things might be spelled a certain way. They might know why what a special character might represent and what business teams might rely on that. So it's not always obvious right on the face of how you should be cleaning your data. And that's the power of developing ML not in a vacuum. So we have our standardized data. Let's start matching. We start with the input value of Stark Industries, totally real advertiser. And remember, this has already been cleaned up. Then we apply some light like preparation that's like specific to the model, but the business doesn't really care about it. So it's not really going anywhere past the model. So like in this instance, we're lowercasing the strings. And then we remove stop words, and we break up the strings into tokens. So stop words. They're any common words that don't have any contextual significance to your data. So there's two types. There's general stop words. This is words like the and that. And then you have industry-specific or dataset-specific stop words. So think of, in our case, something like advertiser or media or even incorporated. So then we tokenize it once we've removed the stop words, which just means we broke the string up into meaningful parts. And finally, we generate sparse and dense numeric encodings. The algorithm that we used was TF-IDF. This is token frequency inverse document frequency. Essentially what this is you count the number of times a token comes up in your data, so in a column in our case, and then you look at the size of that column. And so you may be able to see that, yes, we have 6 instances of this token coming up, but as the number of documents increase, that has an inverse effect on how important that token is within your data set. All right, so here's an example of what a part of a graph might look like. So each vertex represents one account name. Specifically, it's an original domain business data with the features. And then each edge is a blocking key. So in this case, we use location as our blocking key. And a blocking key is a field that is deemed to be significant in finding potential matches and can significantly reduce the search space. So that's the part that's really important. That's where you go from having a ton of matches and really starting to intelligently score what matches might actually be valid. So you can see here, AmeriCar Automotive of Tracy FCA. You have AmeriCar of Tracy, and then AmeriCar Automotive Repair. When you just look at these, they appear to be potential matches, right? You don't know, but you think they could be based on the name. But then when you add in your blocking key, which is location, you can clearly see that AmeriCar Automotive Repair is based out of Atlanta, so it's just an entirely different business. So this is just 3, but imagine this at scale. So you could have hundreds of potential matches, and we did see that just from one account. But working with the business to actually understand the significant fields that help you narrow down that search space, like really reduces the potential matches that you're going through. For example, you could be narrowing it down from hundreds of matches to just 10, which that is an achievable number for actually validating your matches. All right, so there was a part that's missing, right? Because again, we're back to just engineering. This is a machine learning model, which means it needs to train over time. So to do that, we want to have real life human beings going through the proposed matches and checking yes or no on it, just like George Strait. So this is where you come back to data governance. A great place to start for the people that you might want to help you validate your matches and train your model are your domain SMEs and your data stewards. These are the people who understand the matches. Again, they understand really what to look for, and they might be working with accounts, so they know whether these accounts are matches or not. And then once we have the proposed matches labeled, we can feed it back into the model and train it and get even better results the next time. Okay, so that's a lot of nerdy ML talk, but here are the outcomes. So over the course of the work, we spent refining our features, spent time refining our features. We tried a few different distance metrics, a few different blocking keys, until we kind of hit a sweet spot with our similarity scores. And in the end, we were able to run this model against just hundreds of thousands of advertisers, agencies, and contacts. And we were able to achieve, average across it, 65% reduction of duplicates. So this is significant, right? So we're talking hundreds of thousands. Comcast obviously has plenty of advertisers, but this is where we can really start to see what we can eliminate from our CRM system. So we put this into place that can be applied to other data sets. So both a technical process and a people process, because that's where we start to see this really be enabled. And in the end, we have a pretty clear roadmap of where to go next. We have 2 data domains governed, and this is expanded just from, these numbers are from when we put this presentation together, but we're able to rapidly start to expand the data domains that we've applied this to.